Okay, good afternoon, pilot teachers, and good afternoon, students. Good afternoon. Thank you, sit down. Okay, welcome back again to our presentation of work, and what we are basically doing is we're looking at the conclusion of our work on the rocks, and what we have covered on the rocks we are summarizing by looking at students' presentation, and those presentations should show the rock cycle and how best you have understood the work that we have covered by putting the different processes into a diagrammatic type information, and that diagrammatic type information is all about the rock cycle. So we are now looking at the completion of our work, summarizing what we have covered on the rocks by looking at the rock cycle. We looked at 3 groups and their presentations in our last lesson, and today we will move on to looking at the last 2 groups and their presentation of the work on the rock cycle. I will now call upon the 4th group to do their presentation and their explanation. Okay, it's over to you now, group 4.
Good afternoon, class. Firstly, I will be talking about a rock cycle. Rocks are classified into 3 groups, which are Igneous Rocks, Metamorphic Rocks, and Sedimentary Rocks. Rocks form from a liquid volcanic rocks cooled and solidified to form igneous rocks. Rocks formed from the rock particles which are cemented together are classified as a sedimentary rocks. Metamorphic rocks are formed when heat and pressure change igneous and sedimentary rocks. Rocks can be changed from one kind to another. The process by which rocks change is called a rock cycle.
I'll start our rock cycle with the sedimentary rock. The rocks which are exposed on the surface are broken down through the process of weathering. The rock particles are then transported and deposited by water, wind, and ice through the process of erosion. The continuous deposition of rock particles are compact and consolidated to form sedimentary rocks, which are usually deposited in layered sequence. The youngest rock on the top and the oldest rock on the bottom. The sedimentary rock can be then exposed back to the surface or can be metamorphized by heat and pressure.
Metamorphic rocks are those that are produced by the action of heat, pressure on the rock of igneous and sedimentary or even previous metamorphic origin, thus changing the distinctive features which include the appearance and chemical composition.
The metamorphic rocks here can be classified under 4 main groups. Firstly, the regional metamorphic rocks. These are rocks formed from heat and pressure. Second is the metasomatic metamorphism. These are rocks formed from a change in the character of the chemical composition. This can be through an addition of the chemical composition or elimination of chemicals. Then is the contact metamorphism. These are rocks formed from high temperatures And then dynamic metamorphism. These are rocks formed from direct pressure. Pressure is applied to this of two kinds. First, there's the compressive stress. This is where minerals are perpendicularly aligned with the rock. And the second is shearing, by which the crystals are parallelly aligned with the rock to the pressure. Marble here is formed from limestone. Mudstone is formed from gneiss. Gneiss, also from gneiss, migmatite is formed. Graphite is formed from sandstone. Okay. Yep, that's it.
Continue on on the process. I'm gonna just give the definition of igneous rocks, and my friend Elsie will conclude on the process. Igneous rocks are formed under the surface. Igneous rocks are formed by cooling and the crystallization or solidification of magma, which gives rise to one or more rock type according to the composition of magma and the size and the site of its solidification.
The two groups in which igneous rocks are classified under is plutonic and volcanic, which is also extrusive and intrusive. Plutonic rocks, plutonic intrusive rocks are formed under the surface. The crystals are large. And due to slow cooling and solidification within the surface. Examples of intrusive rocks are diorite and cabrol. Extrusive rocks are formed on the surface. The crystals are fine due to rapid cooling on the Earth's surface. Okay. The extrusive features which are exposed on the surface are then subject to erosion and weathering, and the process continues. On our rock cycle, we have igneous as the final stage, but the rock cycle is an ongoing process. Thank you.
Okay, thank you to Group 4. Their rock cycle here, the chart summarizing their group work and their understanding on what we have covered on rocks. We'll just make one correction so that we know that we were aware of that particular error that was made. And that was the one that Silo gave on graphite. Graphite is a metamorphic rock, we agree with her, formed from coal, yes. It will be quartzite from sandstone. Okay, and that's a minor correction that had to be made. But otherwise, the presentation for Group 4, well done. And you did very well on the explaining of the rock cycle. Thank you. We'll have the last and the final group, and that's Group 5.
Good afternoon. Firstly, I will define what is a rock cycle. The series of processes over a long period of time by which rocks on the Earth are changed from one kind to another. They are broken down on the surface by physical or chemical means and are altered or even melted within the crust. Eventually, the new rocks is brought back to the surface by great movement on the earth or by volcano, and the cycle started again.
We, we begin our cycle at the igneous rocks. Igneous rocks here, they are formed from the cooling and crystallizing of magma and solidifying of magma. And as they've explained before, they give rise to one or more rock types according to the composition of magma, the size and the site of its solidification. In igneous rocks here, there are two types of rock. There's plutonic igneous rocks and volcanic igneous rocks, intrusive and extrusive. Extrusive rocks, they are volcanic, as I've said, and they contain small or very fine crystals and cool rapidly due to the exposure of air on the surface.
Intrusive. These are rocks formed under the surface and are called plutonic igneous rocks. These are rocks that have large crystals and cool slowly. These rocks are then brought up to the surface by uplift due to plate tectonic and through rapid erosion.
From igneous rocks to sedimentary rocks, they go through the process of weathering and erosion. And they're carried away. I mean, the process of transportation, process of transportation takes place here, whereby grinding, sorting, and deposition and lithification occurs. Okay, and lithification, she's gonna explain it.
The process of lithification, this is when loose sediments are converted to sedimentary rock. At this, two processes happen in this. That's compaction and cementation. Compaction is the process by which weight is exerted onto the loose sediments and excess water are forced out. At this point, that's when the cementation process occurs. That's when finally the particles are binded together and they form a cement.
Sedimentary rocks are rocks formed from the accumulation of weathered and eroded materials and are usually deposited in layered sequence. Two characteristics of sedimentary rocks are they can contain fossils and they are non-crystalline. There are three types of sedimentary rocks. There's the clastic, chemical, and organic. An example of the clastic is mudstone, of the chemical is limestone, and of organic is oil shale. Thank you.
My colleague and I are here to talk to you about metamorphism. Metamorphism process which occurs, as you can see on the diagram. Metamorphic rock is a rock which has been changed by heat, intensive heat or pressure. Metamorphism implies an increase in hardness, and resistance to erosion. Differential and compressive stress are applied to sedimentary rocks to form metamorphic rocks. For example, shale, for example, may be metamorphosed by pressure into slate, sandstone by heat into quartzite, limestone into marble. Metamorphism of pre-existing rocks is associated with the process of folding, faulting, and volcanicity. There are four types of metamorphic rocks: contact metamorphism, regional metamorphism, metasomatic morphism, and dynamic metamorphism. Metamorphic rocks owes its characteristic textures and particular mineral content to several factors, which are composition of the parent rock before metamorphism, temperature and pressure during metamorphism, effect of tectonic forces, and the effect of fluids such as water. Some examples of metamorphic rocks are limestone, granite, sandstone, coal, and clay. For further explanation, I'll hand it over to my friend here. He will explain more about metamorphism.
Okay. Deep within the Earth's crust, high pressures and temperatures occur. When these high pressures and temperatures are applied to these rocks, which are sedimentary rocks, the process of change is called metamorphism, and the new rocks formed in this way are known as metamorphic rocks. Yeah, this one. Metamorphism usually makes rocks hard and look different. As you can see on this rock cycle drawn by our friend, sedimentary rocks are changed by high temperatures or pressures to form metamorphic rocks, which melts at very high temperature to form magma, which then forms igneous rocks. After a long period of time, the rocks formed might be uplifted, uplifted, and weathering and erosion can then take place, and so the cycle continues. Thank you.
Okay, and thank you then to Group 5. Again, a very good presentation. And for all the students who have done their presentation, you've done very well here. This presentation will also tell me that you have understood what we have covered on the 3 basic categories of rocks and the many different processes which are involved in the formation of those 3 different groups of rocks. Okay, to finish off the work now that we've done on the rock cycle, I'll go through 2 samples from the monitor. And when I go through those 2 samples, you would have already covered most of those from your explanations. So we could just recap again on what we have done to finish off the work on rock cycle. Okay, note there from the monitor, it tells us that a convenient way of summarizing the relationship that exists between the 3 groups of rocks that we have studied about is by using a diagram. Similar to what we have done on the rock cycle, we could also put the water cycle to show the different processes. But we are not looking at the water cycle, we are looking at the rock cycle. So here we have shown examples of how we can display the information about the different processes that are involved in the formation of the 3 groups of rocks on a diagram. This representation of rock genesis or origin, it serves to emphasize the dynamic nature of processes which occur in our lithosphere. We also need to bear in mind that the formation of the 3 groups of rocks that we have looked at can be on the surface, as shown by this diagram here, and it can also be under the surface. And those that are under the surface will get exposed on the surface through processes such as tectonic uplifting, volcanicity, and etc. Okay, let's look at least 3 samples of what I have put together, and those samples are very similar to the 5 explanations and the 5 charts that you have displayed over the 2 days that we have spent on looking at the rock cycle. Okay, the first one there, the diagram, a very simple diagram. You can see the arrows are important because the arrows shows the relationship between one group of rock to the next, and also the different stages that the different rocks can actually go through from one stage to the next. And because this is a cycle, there is actually no start to it. Wherever we start, we can always finish off again in that area. So here we are looking at, say for example, if we decided to use this diagram and we started on this side. Here it says erosion of all surface rocks. All those rocks that are on the surface gets to be eroded. Then you have the transportation of the detritus or the debris or the material which have been broken down. So the next arrow will represent or show that, the transportation. Then comes the deposition of sediments. That's from this point to that point. Upon the deposition, we have the lithification process. We know that already from what we have covered. Then comes burial. And when those deposited materials are buried, they go now through the process of metamorphism. Heat and pressure exerted, resulting in changes in the crystal structure, appearance, composition of the rock. Then through folding and uplift, those rocks which have been buried then get to be exposed. Volcanism is an example that can also aid in the uplifting of those rocks which have been buried. And then those that come up to the surface as a result of uplift go through the process of erosion again, and then the cycle continues. Okay, that's what we have looked at. Let's look at another sample, different ways in which we can present the same information. We now have a flow chart, a flow diagram to show that information, and some of the groups, they also had flow charts to explain the rock cycle. So we might start with the igneous rocks here. Note, for the igneous rocks to go through the process and change to metamorphic rocks, they would have to be recrystallized. For metamorphic rocks to actually change to igneous, they would have to go through the process of melting. So the arrows here will indicate here recrystallizing of igneous to metamorphic and the melting of metamorphic rocks to igneous. But that's not all. Sedimentary rocks go through the process of metamorphism under great heat and pressure. Then they can change to metamorphic rocks. To expand on that particular diagram, here we have sedimentary rocks, but before sedimentary rocks are formed, note, igneous rocks, metamorphic rocks, or even previous sedimentary rocks can be weathered. And when they are weathered, they are broken down into sediments or particles, of which those sediments are actually moved through the process of what we call mass wasting. And in mass wasting or mass mantle, as stated here, those weathered materials from either sedimentary, metamorphic, or igneous are transported. And upon transportation, they get to be deposited. And when they are deposited, that's when we have the consolidating of those grains or sediments. They go through the process of consolidation and cementation, which is lithification. Sedimentary rocks are formed. They can be buried to form metamorphic rocks. And then once under the surface, they can go through the process of melting to give the igneous rocks, and the cycle or the process continues. The arrows are important in a flow chart to show that information, because the arrows, they also show us the relationship between one group to the next, and it also shows the processes in the development of one stage to the next. Okay, and finally, same information that we've looked at, this time similar perhaps to some of the groups in cycle form again. We start off from here, magma, cooling, crystallizing, forms igneous rocks. They can be intrusive, it could be extrusive. Once exposed, erosion and weathering takes place. Sediments are formed then from weathering. Deposition of the sediments then through the process of lithification will form the sedimentary rocks. Once the sedimentary rocks get to be buried, then what can happen is they can change from sedimentary to metamorphic. Those metamorphic then go through the process of melting under the surface. They form magma, and then magma cools again to form the igneous rocks, and the cycle continues. Okay, and basically, those three examples then will show us, or should summarize altogether what we have done on the rock cycle. Okay, anyone with any queries or questions now that you would like to ask with regards to what we have covered? Queries, questions? You might perhaps think up some questions later. And since you do not have any queries or questions, I'm going to give you an activity that I'd like you to do. And from that activity, perhaps you can also do that work for your homework, and you come back with your answers for us to actually correct in our next lesson. Let's look at the last activity I'd like us to do on rocks, and the activity from the monitor reads, you will see there that there is a list of minerals which are listed or given below. If you look very carefully at those different minerals, some of them are ores, and some of those are precious stones. You're going to actually use a dictionary or an encyclopedia to help you divide those minerals into two groups. And for each of the two groups, you are going to actually identify from that list which of those are examples of precious stones, and you put them in one group or under one column, and which of those are examples of ores, and you put them in the next column. So 2 columns for that activity. Okay, then the next thing you are going to actually do after you have identified from the list here, those different minerals, which ones are ores and which ones are precious stones, you put them into the 2 columns. Then the next thing that you are going to actually do after you have put those minerals into those 2 groups, what I would like you to do next is actually, for each of the ore, those minerals that you have identified that they are ores, for each of those, state the metal in which they are actually obtained from. But for you to be able to do that, first things first, you decide which of those are examples of ores, which of those are examples of precious stones. Then you look at the column that contains the ores, and I'd like you to state the metal which is actually obtained from those minerals that you have actually put under the heading ores. That's number 2. Number 3, activity 3. For each of the precious stones, you should already know from what you would have done in activity 1. For each of the precious stone, I'd like you to give the color. Okay, and looking at those minerals that you are going to actually put into those 2 groups, and then state the ores, which metal is actually obtained, and then for each of the precious stone, you give its color. Those minerals are diamond, you have chalcopyrite, galena, opal, hematite, ruby, emerald, and bauxite. Those are the 8 minerals that you are going to actually use for the completion of the activities. Okay, and finally, activity number 4. I'd like you to also explain the difference between ore and precious stone. So I'll repeat the homework or the activity I'd like you to work on. You have a list of minerals that are given. You can use a dictionary or an encyclopedia to help you. Divide them into 2 groups. The 2 groups should have a heading, ores, and the other, precious stone. Put those minerals under the correct heading. For each of the ores, you state the metal which is obtained. For each of the precious stone, you give the color, or you give its color. And finally, explain the difference between ore and precious stone. Okay, those then would be your activities for your homework to actually complete. Okay, with that information, that will also bring us to the end of our lesson. And thank you to all the groups for your presentation. Class, if you can now stand up. To the pilot teachers, our keyword for lesson 61 is rock summary. Good afternoon and thank you, students.